Okay, so let's look at some of this book homework, and this is section, what is it, 3.4. All right, so on the first one, why do we add the way we add? Well, again, if you think of pizzas, and it's not easy to cut, and they have to be the same size, and pretend those are the same size, and I'm set 6 cuts make 7 things. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Do I have? No, I only have 6, Julie. All right, let me try again. So 1, I guess since I'm cutting in a circle, we're not quite, we don't have that end. 1, 2, 3, 4, 5, 6, 7. All right, so ignore that. Need to move those over a little bit. Yeah. Since we have a circle, the rules are a little different there. But 1, 2, 3, 4, 5. Okay, just get your 7. Okay. Here I have 2, and over here I have 1. So the reason I can add these is because of their same unit. The slices are all the same size. So just like adding 2 centimeters plus 1 centimeter, you get 3 of that unit. 3 centimeters, same thing here. I have 2 slices that are in a pizza that they cut in 7ths. I have another slice from a pizza that they cut in 7ths. They're both like mediums or larges. They're the same size. So I can just count my unit, or like my number, how many slices do I have? And then the denominator is just the unit. That's just your label. So I have 2 of something plus 1 of exactly the same thing. I can say that I have 3 of whatever that is. So 2 dogs plus 1 dog equals 3 dogs, okay? Or 2 apples plus 1 apple equals 3 apples. 2 1/7 plus 1 1/7 gives you 3 sets of 1/7, and we write it like that. All right, this one, we do not have a common unit. So this would be like trying to add, inches and centimeters. Doesn't work very well. They're not the same. So we need to get a common denominator, which is going to be 12. And so times 4 times 4, and then times 3 times 3. All right, so we're trying to get them in the same unit. Now, why does that even do that? Like, why does multiplying this by 4 and that by 4 and this by 3 and that by 3, why does that even help? All right, so what's happening there? All right, so again, pretend I have pizzas that are the same size. Kids can only do thirds if they know the peace sign, then they can do it. And I have 2/3. Right, and then over here I have 3/4. So I'm going to cut that guy into 4s. So 3/4. All right, and so what's happening is I'm cutting them to be in the same size. And since these are already cut in 3rds and 4s, my least common multiple, like when are they going to line up again, is by cutting them in 12. So if I cut like these in half, I get 6. Cut these in half, so I get 8. You know what I mean? Trying to find that number that I can do the both. So that's 12. Now, to get 4 segments, since they're already made, I have an N now. It takes 3 cuts to make 4 things if it's already made. So I'm going to do 3 cuts. So 1, 2, 3. And do you see how I get 4 pieces out of it? So I multiply by 4 because I'm converting what used to be 1 piece into now 4. So then if I do that twice, so 3 cuts, 1, 2, 3 to make 4 things, and then 1, 2, 3 in my empty space. What used to be 2 large slices, if they're each worth 4 little slices, is now 8. And then over here, same thing. I don't want to cut it the same way. I need each one to be worth 3 pieces, so 2 cuts. So I'm going to do 1, 2 cuts there, 1, 2 cuts there, 1, 2 cuts there in the empty space. So each big slice is worth 3 little slices, and so I'm conversion there, 9. That would be the same as me taking inches and multiplying by, I think it's I think there's 2.34 centimeters per inch. I think maybe it's 2.54. Sorry, I think it's 2.54. Don't quote me on that. So if I do this conversion, if I take 3 inches times 2.54, then I would have centimeters here, and then I could add centimeters and centimeters. So we're getting the same unit. So once you have the same unit, you can add, okay, because you have 8 slices and 9 slices. They're all the same size, and you get 12. Now, at this point, you can regroup. So I am missing what? Let's see, over here I have 9 slices, so it needs, what, 3 more? So I could take 3 of these slices, and I could move them over here to kind of put that in a pizza box and fill it in. And then what's left are my 5 slices. So it's kind of like you take these 12 and you put them in a pizza box, right? That takes up 12. That's a whole pizza. And then you have this 13, 14, 15, 16, 17 slices left. So you make a whole pizza. And then after you take away the 12 that it takes for the whole pizza, you have 5 left. which is the same as if I take those pizzas, slide over, then I have 5 left here. All right, so this one talks about making it improper in that connection. All right, so I'm going to use hexagons because they work nice with 6s. You could use pizzas, but our pattern blocks are kind of nice. So, and then I have my green triangles. Okay, so my holes are these guys, and then my 6s are these. And so I have 3 holes and 5. All right, so the algorithm is to take 3 times 6, which is 18, and then add that. So that's what, 23, 6. All right, so why does that make sense? Well, again, you have 3 holes, and if you convert them into triangles, each hole has a value of 6. And remember when we learned multiplication, one definition was 3 groups of 6. So instead of counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, that doesn't make sense. You have 3 groups of 6. And remember, 3 groups of 6 is multiplication. I have 3 groups of 6. That gives me 18 triangles. Plus, I have these 5 extra triangles over here. So that's why you take the 3 times the 6, because that gives you the slices from the whole things. And then you add in your little extras. And that's how you make an improper fraction. All right, the next one talks about using a double number line. I'm just going to use a single number line and then mark the tops and the bottoms differently. And I'm going to put a few whole marks. So my big ticks are going to be whole numbers. So I'm going to start 0, 1, 2, and 3, and 4. And if my big ticks are these, then I'm going to pick fractions. I'm going to just do a third. So I'm going to cut 2 cuts in each. And again, try to get them as spaced out perfectly as you can. And so what I'm going to do is I am going to count by thirds on top. So this is 1/3, 2/3. And when I hit 3/3, I'm going to regroup. And then I'm going to have 1 1/3, 1 2/3. When I hit a full amount, I'm going to regroup. So then 2 1/3, 2 2/3. When I hit 3, I regroup. 3 1/3, 3 2/3. When I hit 3, I regroup into 4. And again, that's base 3, right? So when you hit 3/3, you regroup into a whole. 1 1/3, 2 1/3. When you hit 3/3, you regroup into a whole. Now on bottom, I'm going to count by just strictly 1/3. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, and so forth, right? So I'm just using the same number line. And again, if you want to make a double number line, then what we do is just kind of draw a second one. But you can write on top and bottom because these are equal. All right, so if I want to show, like, for example, this point right here, why is 2 2/3 equal to, what, 8/3? And why does the algorithm work? Well, first of all, they line up on the number line together, so they have to be equal. But the other reason is, why do I take 2 times 3? Because each unit of 1 is cut into a distance of 3. So there's 1, 2, 3, like, segments in that one, another 3 segments in that one. So the 2 has 3 segments in it, so that gives you 6. And then I'm adding the extra 2 segments past my 2. So I have 3 segments, that's my 2 times 3 is 6 segments, and then 2 extra. But the other reason, obviously, is that they do line up on the number line. All right, let's look at number 5. All right, so number 5, if I have for I have 2.34. And again, the way we pronounce that is 2 34/100ths. All right, so let's do this by place value here. So how do you convert this into a fraction? So I have this. I have 2 wholes, 3 tenths, and 4 hundredths. So now again, these are called decimal fractions, excuse me, because you pronounce it the same way. This is 3 tenths. This is 4 hundredths. When you pronounce it, you don't know if you should be writing this or this. All right, get a common denominator. So you get 2 30/100ths plus 40/100ths. And so if you add that, you get 2, oh, why did I say 40? Sorry, that's already a 4. 4, so you get 2 34/100ths. And notice that's how we pronounced it to begin with. I mean, I said this is 2 and 34. And remember, the last spot gives you the name here behind the decimal. And the point is your and. So 2 and 34/100ths. I mean, that mixed number is exactly what it is as a decimal. All right, let's look at the next one. So 124.5. All All right, that's kind of the lazy way of saying it. So it's really 124 and 5/10. But let's write it out by place value. So we have 100, we have 20, we have a 4, and we have a 0.5. These are all whole numbers. This guy is 5/10 because the 5 is in the tenths position. So I'm going to write 5/10. So then again, if I add these up, I have 124. And I have what? 5/10 right there. So that's how it would look. Now, if I wanted this as a fraction in reduced form, then you'd have to realize that I could divide by 5, and get a half. So that's how you convert decimals to fractions when, you know, they're kind of maybe not easy ones to do. All right, let's do it this one here. All right, so 7.938 or 7 and 938 thousandths, because that's that guy. All right, so I have 7, I have 0.9 plus 0.03 plus 0.008. Hopefully I wrote it down right. All right, so now the 7 is fine. This is 9/10. This is 3/100. This is 8/1000ths based on their place value. Tenths, hundredths, thousandths, tenths, hundredths, thousandths. All right, so if I get a common denominator, let's see, I'm going to multiply this guy by 10 and by 10. This guy by what? 100 and 100, because my common denominator is thousands. So 7 plus 900,000, or 900 over 1,000, 30 over 8,000, and 8 over 8,000. So if I add that, I get 7, and then I have 938 in that unit. See, there we go. All right, and so then if I want to pronounce it, again, it's 7 and 938, and the last guy gives you the name, thousandths. Now, again, if this is, you needed this in reduced form or something, you know, you might have to, you know, divide this by 2, divide this by 2, so kind of get it out of 500, and then, you know, let's see what's that, 938 divided by 2 is what, 4... 13 is 6, which is that 1, is that right? I think so. 469 times 2 is 18, 12, 13, is that 938? Yeah, so 469. And then, you know, you might have to check some more, you know, is there other things that they have in common? But you're probably good, but you might need to check a little bit more, depending on, when we get into talking about how do you know when you're done simplifying a fraction later, we'll do that. Okay, it says, based on your results, describe a quick way to rewrite this decimal. All right, so a quick way of rewriting, and they give us, let's see, 48.963. So again, the quick way of writing it is just the way you say it. So take your whole numbers, so you have 200 or 2,748, and is your fraction, right? The way you pronounce it. So we would pronounce this 963, and the last digit determines the name. So tenths, hundredths, thousandths. So you don't have to go through all that work because the whole number is your front number, and then whatever's behind the decimal, however you say it, which again is that last place value, is the pronunciation. So 2,748 and 963 thousandths. So that would be the quick way of doing it. And again, you might have to simplify if that is what they want. All right, let's see. We have a little time. I think I'm going to wait till the next video and then I'll start that. So hopefully these went okay, and we'll pick up with another video.